Hello, I am Michael Woods, the Chief Scientist at the Asian Turfgrass Center. Welcome to the ATC Double Cut. In this episode, I'm going to talk about two blog posts that I've put up recently on the ATC website, and I'm going to try to explain them. Now, this may be a bit of a difficult episode for me. I've been thinking about this for a while, about how I'm going to explain one of these, because when I wrote it, I got a bit of feedback that it was confusing. And I think that this is something that I meant to make this post, make it simple. But I think because I showed some of my work and because I showed some of the intermediate calculations, I realized that perhaps it didn't quite have the intended effect. And I thought on the ATC double cut, it is a perfect chance for me to try to explain it a little bit better, because the point of this is not to work through all the nitty gritty details, but it's like having a conversation with my friends, explaining why I wrote what I wrote and why I think that topic is worth having another look at, or worth taking your time to read. I'll start sharing my screen and show the first blog post. Now, this one I think is pretty simple. It's about clipping volume. This is a post that I gave a title of Grass Clippings Year to Date. Clipping volume, if you don't know, is simply recording the volume of the clippings that are harvested when you cut the grass. It is common on golf course putting greens, on golf course tees, on high quality sports fields, on some golf course fairways, on high quality lawns. It is common to collect the clippings to make the finished surface a little bit cleaner and to have no debris there. In fact, I had a conversation last week about the ideal way to mow airport grass. You know, all the grass on airports, which can be some substantial acreage. And you don't want grass clippings there either, because that can be some living quarters for wildlife that could attract birds. And it could also be grass clippings that could be substantial enough to blow out onto the runway and get ingested into engines and cause safety hazards. So grass clippings are sometimes collected from all different types of turf. Generally, on golf courses, it is customary to collect grass clippings from the putting greens, and that's the area that's most intensively managed. So this is something that I have been talking about and recommending since about 2014, collecting the clipping volume and saying that that is a useful number. But I'm a slow adopter. I first found out about this in the year 2000 when I was a golf course superintendent in Japan. And in fact, we were collecting some clipping volume data back then, but I didn't pay attention to it because it did not make sense to me. I couldn't figure out what the connection was between the exact clipping amount and anything that I might want to accomplish, because I was not thinking about greenkeeping as deeply as I do now, and I didn't have as much experience as I do now. And now I realize that getting the growth rate right is incredibly important in terms of producing the type of surface that we want. And then I realize that so much of the work that gets done, whether that is supplying irrigation water or supplying fertilizer or doing mowing or adding growth regulators, so much of that work is related to the growth rate, either to drive the growth rate, to adjust the growth rate, or the work has to be done in response to the growth rate. And then there's other things that follow on from that that also happen because of the growth rate, such as the amount of cultivation and organic matter management and sand top dressing that needs to be done, and so on. So clipping volume is something that I initially didn't think was so useful. Then for the past 8 years or so, I've thought it is quite useful, and I've been recommending it. And it turns out that more and more people around the world finally give it a try, and I can understand completely why they initially don't, because I think for the same reason that I didn't. It's just hard to see how doing something like that could be helpful, and it seems like it might be a lot of work and too variable and so on and so forth. But then once you start doing it, it becomes pretty easy. But then everybody runs into a problem of what to do with the data, how to look at the data. And in this blog post, which I will put a direct link to in the show notes, so you can check it out and read it and see this example chart that I'm going to show on my screen here. The post is titled Grass Clippings Year to Date, and I show a way that I think is quite useful to look at the clipping data, at the clipping volume data, and that is as a cumulative amount through the year. And specifically, I like to look at it as a cumulative amount through the year on a green by green basis. So on a golf course, if we are measuring the clippings on all the greens, or if we're measuring the clippings on certain individual greens, you can plot those greens individually, and then by looking at it this way as a cumulative amount through the year, you can compare how much it's growing this year to previous years at a glance, and you can also compare how it's growing this year on a individual green or on a single location compared to the average across the entire property, how much the grass is growing across the entire property. So it becomes very easy to identify just by looking at this simple type of chart if your grass is growing more or less than last year or the same. And also you can identify which greens are producing more clippings and which are producing less, and which ones are right around the average. So what you do, and this is a chart that I put together for in 2022 for one of ATC's collaborators and clients, and I showed the front nine data on greens 1 to 9 because at this golf course the clipping volume is measured on all the greens, and starting in the spring of this year, in the middle of April, going up until October 1st, I plotted the cumulative clipping volume, and that is shown in green on this chart. So on the horizontal x-axis, it's showing the dates through the year, and then each green is a panel, and it's got a line on it, and that green line is the data from this year, and the orange line is data from last year from that same green. So you can see all you have to do is look at the green line or the orange line, and you see if the green line is above the orange line, that means that it's growing more this year than it did last year. If the green line is below the orange line, then that means that particular green is growing less or producing fewer clippings than it did in the previous year. And you can also look at the purple line, which I put on the chart. The purple line shows the average for the year 2022 for the current year. And so you can see how last year compared to this year on average, and then you can see how this green compares to the average across the entire property. So this type of chart, I think, is quite interesting to look at because it shows you how the grass is growing, not so much on a day-to-day basis, but season long. And that can be useful to diagnose some issues that may be happening. So for example, I see that the eighth green is growing less than the overall average. And in fact, not only is it growing less than the overall average, but up to October 1st of this year, it's growing less than it did last year also. So that green, it grew less than it's growing less than average. It's also growing less than it did last year. Now, maybe that's meaningless, but for the golf course superintendent to be able to look at that just at a glance and see, okay, that's what's going on with that green, maybe I will go check and see uh, if maybe that green needs some extra fertilizer. Or you can see when you start getting into really site specific management, I think this can be useful. And it can also be a way to diagnose problems. The fifth green on this course is growing a little bit more than average. So it's growing more than the average green this year. So that type of thing for me is interesting to look at, because if the fifth green is performing a little bit differently in terms of playing performance, then it would be useful to know if that green is, well, at least you know, okay, it's not that this green isn't growing enough that's causing the problem, right? So you can look at this cumulative amount on a green by green basis. So it's pretty easy to do these type of cumulative sums, and it is something that I've recommended before, and I just want to make sure that everybody's aware of that as a way to look at clipping volume data. Just take you start the year at 0. The first time you mow, you take that amount, and then the second time you mow, you add that to that amount. So you can just have um, a running total, a running sum, and you just keep adding it up through the year. And then by the end of the year, you get the total amount. And that total amount can be useful also, because when you look at the total amount through the year, you can then start comparing it to previous years and saying, okay, if I top dressed so much last year and got a good result, and my grass grew 20% more this year, for example, maybe I should put 20% more sand. There's those type of things that I think should be related to the growth rate. So that's one post that I have written recently and I wanted to share. And now I'm going to get to the part that I think is going to be a little bit trickier for me. So I'm going to try really, really hard to explain this as if, let me just find that post. Going to try to explain this as if I'm trying to keep it really simple and explain why I even wrote this, because this is a post that I've brought up now that has a title of fertilizer recommendations by 3 different methods: SPF, SLAN, and Mlsn. SPF stands for Sturf Precision Fertilization, or Scandinavian Precision Fertilization. SLAN stands for Sufficiency Level of Available Nutrients. And Mlsn stands for Minimum Levels for Sustainable Nutrition. These are 3 different methods that one can use to interpret soil tests and then calculate a fertilizer recommendation. The reason why I got started writing this post is because I saw a very interesting post on LinkedIn. In fact, it wasn't a post, it was an article. It was an article by 2 authors, Dr. Daniel Hahn and Roman Giraud. I apologize for my French. I don't have a good French pronunciation. But they are quite familiar with Mlsn, and I think they're big fans of Mlsn. They have implemented that in France, in Germany, in other European countries, and they've recommended and they wanted to explain it. So they wrote an excellent article about it on LinkedIn, and they compared Mlsn and SPF, Sturf's Precision Fertilization, which are both excellent methods to make fertilizer recommendations. And so I was quite interested in that, and I read it once and I was struck by a couple of things and I thought about it, and then a week later or so I read it again. I'd made a note that I was going to write a blog about that, and I wanted to read it again and make sure I understood everything. So I did, and I made a couple notes, and then I said, okay, let me get started writing my blog post. So first I dealt with a couple of notes. Um, they'd written in the article, they said that, I'll quote, it is essential to send a sample to a laboratory that uses Malic 3 nutrient extraction if you want to use MLSN. That's the end of the quote. And I I think that's correct. Well, I I wouldn't use the word essential because there's a couple workarounds. I've written an MLSN cheat sheet, and I do recommend, if you're at all interested in this, please do read their article on LinkedIn and go to check out this blog post, which I will put a direct link to in the show notes. And then you can see from that, you can see the MLSN cheat sheet and you can see all the things that I'm linking to. So they'd written this and they said that it's essential to send a sample to a laboratory that uses Malic 3. And I just wanted to soften that a little bit. So I said that I recommend that, but there are some workarounds if you can't get Malic 3 data. You can look at the MLSN cheat sheet. So for example, for phosphorus, we already have a Bray2 and a Olsen phosphorus value that's been in the original MLSN since 2012, actually. And we don't publicize that because I like to keep MLSN as simple as possible. But if you are using MLSN, I would hope that you'd check out the MLSN cheat sheet. And in the cheat sheet, you can find an entire section about what to do if you don't have Malic 3 data. And in that, it includes the Olsen and Bray 2 values for phosphorus. So that's one thing. And then the other really common extractant around the world for potassium and magnesium is 1-normal ammonium acetate. And there's a pretty good relationship between Malic 3 extractable potassium and magnesium and 1-normal ammonium acetate extractable. So you can predict one from the other with relative accuracy, and I would have no hesitation in doing that. So if you have ammonium acetate soil test data, you can use MLSN. You just have to convert a couple of things, and it's explained how to do that in the cheat sheet. And what I really recommend doing, if you really see a use for MLSN in your region and you don't use Malic 3 because that's not what laboratories use in your region, you can do what Gerard has done and calculate a regionally specific MLSN value. And he's done that in France based on his own database of good soil test results from good performing turf. So then you can just use that. So you're still using the MLSN method, but you've calibrated it locally. So that's something that I recommend. And I just wanted to clarify that because I think not absolutely essential. There are some workarounds, and I wanted to point that out because I think the benefit of using MLSN is worth it even if you don't have Malic 3 soil test data. But to use the same kind of thought process and logic that we used to go through with MLSN. The second thing that I wanted to clarify or sort of give a differing opinion on from their article, they wrote, and I'll quote this also, for the MLSN guidelines, it is important to measure the soil nutrient levels at the beginning of the season and at the end of the season. End quote. I I don't actually recommend that. I recommend soil testing once per year, and ideally I like to test at the end of the season. The only place I don't like to test at the end of the season is in a place like Barcelona or Los Angeles, where you have a dry summer with lots of irrigation water, and then you don't have so much growth during the winter and it tends to rain more. So something that's more of a Mediterranean type climate. In a Mediterranean type climate, I think it makes sense to soil test at the end of the rainy period because that's when the soil nutrient levels will be lowest. So in that case, you would test in the spring, and otherwise I like to test in the autumn in places where it rains, somewhere like Chicago, New York City. um, I don't know. I was going to say London, but I think this year it didn't rain so much in London. But in general, I think it makes sense to soil test in the autumn. And there's a few reasons for this, um, which let me see if I can think of the top ones. I think I like soil testing in autumn because it gives us all winter to plan, to apply any amendments for pH, for example, and it gives us all winter to plan for what products we're going to apply the next year and when we're going to apply them, how we're going to apply them. And if we do need to make any significant or substantial applications of amendments, such as liming materials, it gives us a long time to do that before our upcoming growing season. I just feel it's a bit of a rush to test in the springtime when the season is already getting underway and golfers are getting ready to play, or uh, people are wanting to come out and use the turf surfaces, and we just then collect samples and send them to a lab, and right then suddenly we have to rush to make our fertilizer plan for the year. I i just don't think that's an ideal way to do it. And secondly, I think it makes sense to do the soil testing at the time of the year when our soil nutrient levels will be at the lowest. And that tends to be in the autumn in most places, unless you irrigate with slightly saline irrigation water and it doesn't rain during your growing season. In that case, you'll have elevated nutrient levels in the soil in the autumn, and then they decline over the winter as the rains flush some of those salts out, which is another reason why I don't think it makes sense to test twice per year. You don't, if you test at the beginning of the season and at the end of the season, there are weather effects and seasonal effects that can influence your soil test results. So you can't be 100% sure that the differences in the results when you test at two different times of year are related to the nutrients that have been applied and your Mlsn calculations. So when they wrote in that article that for the Mlsn guidelines, it is important to measure the soil nutrient levels at the beginning of the season and at the end of the season, I would change that to be it is important to test once per year. Although if you have soil based, if you have soil with clay and silt in it, you can get away generally with testing every 2 or 3 or 4 years, because things won't change so much. If it's a sand based root zone, I generally recommend testing once per year. So, and I've explained already when I think that should be. So that is another topic for me to explain about the when, um, to try to explain that one really clearly also, because I think that's important. If you test it at different times in the year, you can't be certain that the result is not affected by the season, and we want to eliminate as much unknown variability as possible. So I recommend trying to sample within the same week or 2 weeks every year, and trying to do that at the time of the year when the nutrient levels are at their lowest. And then now we get to the part. Now we get to the part that I have thought, I wonder if I can explain this. I clearly failed to explain it well when I wrote the blog post. And I'm wondering if I can explain it now, because this is something that is clear in my mind, and I didn't know what the exact numbers would be, but I knew what the general result would be. And that is that if you use Mlsn to make fertilizer recommendations, the total amount of fertilizer that gets recommended, not for any one site, but if we just look at the world, if we just look at every turfgrass site in the world, Mlsn is going to prevent nutrient deficiencies, and it ends up being quite an efficient way to do so. And if you use something like SPF, the STIRF precision fertilization approach, because that method does not consider what's in the soil, it ends up recommending nutrients for every soil gets the same recommendation. So it will tend to over recommend because some soils have plenty of nutrients, but it will still get fertilizer recommended. So I guess because I developed the Mlsn guidelines together with PaceTurf, because I updated the Mlsn guidelines, and because I study all these other guidelines, and we developed the Mlsn guidelines in response to the SLAN guidelines. In fact, we developed them as an alternative to the SLAN guidelines, which is what we call the conventional guidelines, because those are the conventional guidelines that are used in the United States and used in many other parts of the world also. So, this is kind of my business, and it's kind of it's my work, it's my job, it's what I do. So I think about this a lot, and I think I just kind of understood that Mlsn, if we apply it to a whole bunch of soils, it's going to result in preventing nutrient deficiencies, but supplying all the nutrients the grass can use, but it will have quite a bit lower overall nutrient supply compared to these other methods. So I had the idea after I read this article on LinkedIn, and I thought, okay, they're getting into the nitty gritty and talking about how you have to use the Malik 3 soil test, and how you have to test twice per year, and how all of these different how you would apply SPF if you were using it. And just it was quite a long article they wrote, but it's very good. It's very good. It's very comprehensive, but it's sort of like how you would use this. And I thought, whoa, let's step back a little bit, because the big picture, I think we should look at the big picture, which is what are the implications of using Mlsn on, for example, on every turfgrass site in the state of New York, versus if we would use SPF on every turfgrass site in the state of New York, or use SLAN on every turfgrass site in the state of New York. Like I tried to simulate what this would be in the big picture. And this this to me seems like an important question to ask, and an important one to develop an answer to, because that basically is what we need to do as an industry, is decide what's the best way to decide how much fertilizer to apply. So I said, let me use their article as a justification to say, let's look at the big picture. So first I made those two direct responses to their article, and then I wrote this. I said, third, I like to put fertilizer recommendations into a larger context. What is really happening when one implements one method of fertilizer recommendation over another? To do that, I considered 1,000 simulated soils or locations and calculated a phosphorus fertilizer recommendation for each of those locations across a range of nitrogen fertilizer inputs. So what I did is I took the global soil survey phosphorus data, and from that we know how phosphorus is distributed on good performing turf grass on multiple soil types around the world. So I simulated that, and from that there were soil test phosphorus levels that ranged from about 3 point, well, this was exact. They ranged in this simulation from 3.3 to 799 milligrams per kilogram, parts per million, on a Malik 3 test. 799 milligrams per kilogram is not unheard of, but it is exceptionally high. And but it turns out that there are some soils that are exceptionally high in phosphorus. And then 3.3 is quite low, but it turns out there's also good turf growing in soils that are that low in phosphorus also. But most of the samples, when I plotted it on a histogram, most of those samples are in the 0 to 200 milligram per kilogram range, 0 to 200 parts per million. But you still get some that are up around 300, 400, 600. And that one sample in this particular simulation was all the way up to 799 parts per million. So I showed that. So this is perhaps only of interest to me. Maybe I should have just jumped right to the conclusion and jumped to the end, but I was trying to show my work, trying to show what I was doing, because I think this is so interesting to just look at what a huge difference there is when you take these type of, this is essentially real. These are simulated data, but this is almost exactly how you would expect real soil test data to be distributed. So this is 1,000 sites, and then for each of those 1,000 sites, they've got a soil test value for phosphorus that ranges from, the lowest one was 3.3, the highest one was 799 parts per million. And then from that, you could apply different nitrogen rates depending on the grass type that you have, or the way that you like to manage, or the use of the turf. You know, if this was a football field, I am sure that it would be getting a nitrogen rate in many parts of the world somewhere, closer to 8 pounds per thousand square feet, 40 grams per kilogram, 400 kilograms of nitrogen per hectare, something like that. Obviously depending on the climate and the grass type and so on. Some places get double that, but not a lot of places get like that. So I only ran the simulation up to 50 grams of nitrogen per square meter, which is 10 pounds of nitrogen per thousand square feet, which for golf course people, they would think that's kind of on the upper end. Even people in tropical areas, that's on the upper end. I mean, some people apply a little bit more, but I didn't want to go too high, because most places in the world are applying somewhere that's in the 0 to, let's say, 30 uh, grams of nitrogen, 0 to 300 kilograms of nitrogen per hectare, or 0 to 6 pounds, something like that. But what I calculated was all the way up to 50 grams of nitrogen per square meter, 500 grams of nitrogen per hectare, 10 pounds of nitrogen per thousand square feet. I calculated up to that level. And then I I explained all my calculations, because I don't know, maybe I thought some people would want to follow it. And then I showed this really complicated chart that has the title Total Phosphorus Recommendation by 3 different methods based on 1,000 simulated Malik 3 soil test phosphorus results. And this is all just showing my work. So I guess maybe it's better targeted for, I mean, I make this for myself. I make this for myself because I'm interested in it. And I guess the only other people that might be interested in it are maybe phosphorus researchers or soil test methodology researchers or something. But I write on my website things that I'm interested in, and I thought this was interesting, and I didn't want to just jump right to the end without showing my work. So I showed my work, and I showed that if we added together for each of those 1,000 sites across 50 different nitrogen rates, so that quickly becomes 50,000 different sites, because we have it's either 1,000 sites with each of them with 50 different nitrogen rates, or we just consider them unique and just say it's 50,000 different sites if we combine the soil test results and the nitrogen rates. So it's a big data set, and then we just add together how much fertilizer got recommended. So I did the Mlsn recommendation for each site. I did the STRF precision fertilization SPF recommended amount for each site, and I did SLAN. And I showed that, and there's 3 different lines. The SPF line is straight because, and it goes up at an angle that's proportional to the nitrogen rate, and that's because the SPF method makes a recommendation for phosphorus that is based simply on how much nitrogen is supplied, and it ignores the soil. So that makes sense. And the SLAN method, it is just completely flat, because the SLAN method does not make any account for what's in the soil. The SLAN method just make the SLAN method doesn't account for the plant use. The SLAN method only accounts for what's in the soil. So because of that, the SLAN recommended amount, the total amount, is just a completely flat line. And then the Mlsn amount curves because it is affected both by the nitrogen rate, which is the expected plant use, and the Mlsn recommendation is also affected by how much is in the soil. So the Mlsn line is the only one that curves, and the STRF line is proportional to the SPF, the STRF precision fertilization method. That is proportional to the nitrogen rate. And then the SLAN recommendation is proportional only to the soil test amount, but it's not changing at all based on how much nitrogen is applied. So I made this complicated chart, which is, again, it's just kind of an intermediate thing, because really I want to compare how much is recommended by these different methods. So then I go down to the final part, which I showed kind of in an inverted way, I've realized. I showed the Mlsn recommendation for phosphorus as a fraction of the SPF or the SLAN recommendations. So in that chart, I showed that Mlsn is anywhere from about 0.6, about 60% of the SPF recommendation, down to about less than something like 0.2, 20% of the SPF recommendation. So basically, if you look across the entire range of possible nitrogen rates across all these soil types, Mlsn would recommend somewhere from 20 to 60% as much P as the SPF method would. And compared to Mlsn compared to SLAN is recommending it's always recommending less until you get up to really, really high nitrogen rates. And once you get up to really, really high nitrogen rates, now Mlsn, because it accounts for plant use, will start recommending more than SLAN. But to do that, you have to get up above 45 grams of nitrogen per square meter per year, which is 450 kilograms of nitrogen per hectare, or 9 pounds. So anything that's less than 9 pounds of nitrogen per 1,000 square feet per year, you can expect that on average, Mlsn is going to be recommending substantially less. And in fact, for normal nitrogen rates that are used on golf course putting greens in many of the temperate areas in the world on cool season grass, you can expect that Mlsn is going to be recommending less than half as much phosphorus as either the SLAN method or the SPF method. So I realized when I did this as a fraction that that chart is also a little bit hard to read, and it would be better to show this as a multiple. So I've got another blog post coming up about that where I take the same calculations that I put in this final summary chart and I inverted it. So instead of showing Mlsn as a fraction of those other methods, I show Mlsn in the denominator and show SPF and SLAN in the numerator, and show it as a multiple. And that makes much more sense. So then you quickly see, instead of looking at this fraction and then trying to figure out how many times more it would take comparing one method to the other, you will be able to see in this upcoming blog post that I think a little bit more clearly that what I was trying to get at was, if we look at the actual soils that exist today, if we look at the types of soils that exist on fine turf areas today, the types of soils that grasses are actually grown in, and we look at the actual nitrogen rates that are applied, the Mlsn method is going to prevent deficiency, but it's also going to recommend probably on average less than half as much phosphorus as these other methods would, at least in year one. Now, compared to SPF, it's always going to recommend less because SPF doesn't account for the soil. So SPF, it's just always going to be recommending based on plant use. But they eventually they might get a little bit closer as the Mlsn method allows the soil to deplete, and then Mlsn eventually would get to the point where it's just recommending plant use also. But the SLAN method, also, this is for year one for phosphorus, but when you over apply phosphorus, hopefully that's just going to stay in the soil. So the next year when you do the soil test, hopefully the SLAN recommendation would be a little bit lower because the excess that was applied in the previous year hopefully would still be in the soil. Now, this is such an interesting exercise for me that I may do this for potassium also. But for potassium, we don't expect that the potassium is going to stick around. So if SLAN makes a recommendation for potassium that is excessive, we don't expect that to be a carryover to the next year. So that potassium would be lost, and you could just have this perpetual year after year over recommendation of fertilizer. So I think this is the reality, and I thought that was so important that we step back and look at the big picture and don't just say, well, I've got a choice that I could use Mlsn, or I've got a choice that I could use SLAN, or I've got a choice that I could use SPF. Of course, everybody's got the choice, or you could do nothing. You could just you could not soil test. You could just you could just do it the way you've always done it. Everybody has a choice how they're going to manage the grass. But I like to consider what would happen if everybody did it this way. What would happen if everybody did it that way? And so I worked through that simulation that I think is quite realistic. It's as far as what the soil test numbers are, what the nitrogen rates are, and what the fertilizer recommendations would be. Those are exact. Those are exact because they are calculated, and they're based on recent soil test data, and they're based on real nitrogen rates, and they're based on real calculations of what the fertilizer recommendations would be. And that's the type of thing that I think we should be considering. If we just look at whether we'll use this particular soil test or whether we'll use that particular interpretation method for a single site, I think it loses Uh, well, of course we have to do that, right, for on a site-by-site basis, but it fails to see the big picture, and the big picture in this case is that we are able to prevent nutrient deficiencies with all of these methods, but the MLSN method is particularly efficient. It is particularly efficient and effective at keeping the nutrients well supplied to the grass and avoiding over application. And if you compare the methods, the MLSN method is basically able to do that at 50% or less in most cases, but it's going to depend on your site and depend on how much nitrogen you're applying. And it also depends on your particular soil test. But if we look at all the soil tests in the world and how those are likely distributed, now we can essentially be looking at all the turf grass in the world, and we can look at all the different grass types and make these kind of simulations. And it turns out that there are some pretty big differences. So I hope that I have explained that well enough that it makes a little bit more sense than that initial blog post did. And as I mentioned, I've got another blog post coming up on asianturfgrass.com where I will show that end chart, and I'm going to skip all those intermediate calculations and just say this is the conclusion. This is what happens if you would make recommendations from these different methods. SLAN and SPF for phosphorus would recommend this many times more phosphorus than MLSN would. All right. Thank you so much for listening. I will be back again soon with more interesting turfgrass information. In the meantime, you can always find information on my website at asianturfgrass.com or on paceturf.org, where I have also been making quite a few updates about a range of topics that I hope you will check out. And if you are not a PaceTurf subscriber yet, please look into that. I think that's another great thing to do if you're in the Northern Hemisphere going into the autumn and winter season. You may have a bit of time to subscribe to PaceTurf and to take advantage of some of the great information resources that are available there. The reference section alone is worth it. Just a few of those documents in the references section, to me, is worth a PaceTurf subscription. It's currently at $275 per year. And other people have told me that the weather updates on their own are worth the subscription. So you get all kinds of things. You get weather updates that are specific to your site, no matter where you are in the world, with disease risk information and growth potential for your site, temperature data, all kinds of things, both historical and some short-term forecasts. And you get also the subscriber only updates that I've been posting there also. So information at asianturfgrass.com, information at paceturf.org. And I am so glad that you find this information useful. I will keep sharing it, and I will sign off now for ATC from Bangkok, Thailand. I am Micah Woods.